Take 37. Hey, what's up, guys? How you doing? My name is Ernesto Cucci, and today we're going to be discussing the research question, are we living in a base reality or is this a simulation? So really what inspired this question was an interview with SpaceX and Tesla CEO Elon Musk.
So the idea is, right, any sufficiently advanced civilization could create a simulation that's like our existence, and so the theory follows that maybe we're in the simulation. Have you thought about this? And
a lot.
Are we?
The strongest argument for us being in a simulation, probably being in a simulation, I think is the following. 40 years ago, we had Pong, like two rectangles and a dot. That
Right.
was what games were. Now, 40 years later, we have photorealistic 3D simulations with millions of people playing simultaneously, and it's getting better every year. And soon we'll have virtual reality, augmented reality. If you assume any rate of improvement at all, then the games will become indistinguishable from reality. So given that we're clearly on a trajectory to have games that are indistinguishable from reality, and those games could be played on any set-top box or on a PC, it seems to follow that the odds that we're in base reality is 1 in billions.
What do you think?
Well, I think it's 1 in billions.
Okay.
Either we're going to create simulations that are indistinguishable from reality, or civilization will cease to exist. Those are the two options.
Pretty crazy, right? So after watching that, I started asking a lot of questions, trying to find different sources that could either support this claim or disprove it. Jeez. And thanks to Professor Geerling, I was able to talk to an author by the name of Cole Bellamy, who's actually writing a book right now on simulated realities. And as we were talking, he showed me something that I thought was pretty cool. It's an interview with a professor from the University of Oxford by the name of Nick Bostrom. And he talks about the simulation argument, where basically it's 3 possibilities for what this existence is. These are those 3.
The 3 propositions in question is first, that almost all civilizations at our stage of technological development go extinct before they reach technological maturity. So that's the first possibility. A second possibility is that there is a very strong convergence among all technologically mature civilizations, in that they all lose interest in creating ancestry simulations, as I call them. These would be very detailed computer simulations of people like their historical forebears, detailed enough that the simulated people in these simulations would be conscious. So the second possibility is that they just lose interest in doing this. And the third possibility is that we are almost certainly living in a simulation. There's a further possibility that if you have a simulated civilization, that simulated civilization might, inside the simulation, develop the technology to run its own simulations. And you might then have a kind of nested simulation, with simulation inside the simulation. You might have many levels of simulation. But that's an option.
So, yeah, there you have it. There's no way to really prove if this is the real world or if this is a simulation. That argument is probably as good as it's gonna get as far as answering that question. Or so I thought. So, after watching that video, I actually stumbled across another one. It's a panel interview with a theoretical physicist by the name of Dr. James Gates.
These are pictures of equations. I've been, for the last 15 years, trying to answer the kinds of questions that my colleagues have been raising. And what I've come to understand is that there are these incredible pictures that contain all the information of a set of equations that are related to string theory. And it's even more bizarre than that, because when you then try to understand these pictures, you find out that buried in them are computer codes just like the type that you find in a browser when you go surf the web. And so I'm left with the puzzle of trying to figure out whether I live in the matrix or not.
Wait, you're blowing my mind at this moment. So you're saying, are you saying your attempt to understand the fundamental operations of nature leads you to a set of equations that are indistinguishable from the equations that drive search engines and browsers on our computers.
That is correct.
As you dig deeper, you find computer code writ in the fabric of the cosmos.
Into the equations that we want to use to describe the cosmos, yes.
Computer code.
Computer code, strings of bits of ones and zeros.
It's not just sort of resembles computer code, you're saying it is computer code.
It's not even just is computer code, it's a special kind of computer code that was invented by a scientist named Claude Shannon in the 1940s. That's what we find very, very deeply inside the equations that occur in string theory and in general in systems that we say are supersymmetric.
Okay, so after watching that video, I need some background knowledge just to help me out to understand it. And I found out what string theory was. Because you see, after watching that, the question transformed into what is string theory. And basically I was watching a video with Dr. Brian Greene, who's another physicist, and he explains that superstring theory is the explanation of other dimensions besides the regular 3 that we can see. And these other dimensions are proven because inside atoms there's electrons, protons, and neutrons, as you know. And inside those elements, inside those electrons, protons, and neutrons, there's circular string, hence string theory.
Familiar object, just a candle and a holder, and imagine that we want to figure out what it is made of. So we go on a journey deep inside the object and examine the constituents. So deep inside, we all know you go sufficiently far down, you have atoms. We also all know that atoms are not the end of the story. They have little electrons that swarm around a central nucleus with neutrons and protons. Even the neutrons and protons have smaller particles inside of them, known as quarks. That is where conventional ideas stop. Here is the new idea of string theory. Deep inside any of these particles, there is something else. The something else is this dancing filament of energy. It looks like a vibrating string. That's where the idea of string theory comes from.
That vibrates, and that vibration is basically the fundamental of the atoms. The fundamental part of the atoms that gives us its shape and its composition. So what I'm trying to understand is, how does someone find computer codes in there?